Here we are going to talk about integration by substitution. So there are many cases that one can find. So let us start by the first case. So whenever you have a function inside your integral and you have its derivative inside, then with respect to x, and then there is nothing else here inside the integral other than the function and its derivative, and it is directly integration by substitution. So let us take one example. For example, let us say so example 1 maybe. So let us say we have integral 2x times 1 plus x squared dx. Of course, here we can multiply and integrate, because here that is simple, meaning the first case it is simple. So but then if you would like to do it by substitution, then we change the variable. We assume so a new variable u that is equal to this function. You see here we have f of x, and here we have its derivative. So whenever you have a function and it is derivative, so it is directly integration by substitution. But then this is a simple case. For example, that could be to the power 10 or to the power 11 or 12 or anything, but that now it is very simple. Let us keep it simple at the beginning. So and then if we assume u to be the function, then the derivative is here, and mean everything here will be du. Let us see how. So here we assume that this is the function, so it's equal to 1 plus x squared, then du by dx. I mean here for now let us do it in this way, but then later we just write du equal and then times dx. So the derivative is 2x, but then that means here du will be equal to, so we multiply here, cross multiplying, then we get 2x times 2x times dx here. So now you see that, so that means here in the integral, so now 2x dx will all be du, and we already have here we assume that to be u, what is inside here. So now that means our integral, main integral, which is 2x times 1 plus x squared dx. So we can write, so now we change the function, which is 1 plus x squared to u, and everything else here is du. So now we integrate, so we just follow the rule. So now this will be u squared divided by 2 plus a constant. So and then here so now we need to resubstitute again. So what was u? So u here is 1 plus x squared, so we must change it to 1 plus x squared, because so the main problem here, the integration was with respect to x, then we must also get the final answer with respect to x. So then here plus a constant. And usually, I mean now here too it is given, but then it does not necessarily to have this number here too. So the numbers are not important, and we will see more complex examples. But now let us here in this case take example 2, for example. So example 2, so we have a function, let us say sine x cosine x dx. So again, whenever you have a function and it is derivative, or even this function and it is derivative, so we don't worry about the negative sign and the numbers when we integrate. So only the main thing is a function and it is derivative. So then that is integration by substitution directly. So here for this case, I mean if we assume u to be the sine, then the derivative of the sine is cosine. So that means cosine x dx here will be du. So now the integration would become very simple. So let us assume y equal sine x. So now we have du. So now from here we already learned that du we can write it directly with respect to dx. So that means here we would have cosine x dx. So now it is simple. As you see here, cosine x dx is du, and then sine x is u. So now, so again we write our integral. That is much better. Cosine x dx. So that will be equal to, now we change the variable so that we need to write the integration in terms of u and du. So, and that is equal to u squared divided by 2 plus a constant. So, and here we also need to replace u and to write it in terms of x as here. So u is equal to sine x, and then to the power 2 divided by 2 plus a constant. So this is one case, and the other case here for the composite, we can, for the composite functions, for example, let us say we have the second case would be the following. So if you have the integration of a function, and then this function is any function that is to any given power, let us say n, and then you have the derivative of this function without n. So the derivative only of f of x, which is f prime of x dx, that is also integration by substitution. So let us take one example. If we have integral, so example here for case 2, let us say example 1, because for case 2 new case. So here let us say x to the power 4, but now we have 2 plus 5 x to the power 5 all to the power 10 dx. So now again we don't need to worry about the numbers, we only look at the exponent and whether this function has a derivative or not. So if we look here inside, for example, then we see that like independent of the numbers, then if we take the derivative, then the exponent will be reduced to x to the power 4 here. So this 5 will be reduced to 4. That means we have a function f of x. Here n is 10, but we don't care about n for now. So we have a function and we can get it as derivative, do some multiplications for those numbers, and then that is of course integration by substitution. And directly we assume u to be the function. So similar to what we did here, let us say u is equal to 2, everything here, plus 5 x to the power 5. So now look here, so now we differentiate, so we take the derivative. So the derivative is of 2 is 0, and then plus, then here that will be 10 x to the power 4, sorry, that is 25, sorry, so that is 25 because we multiply 5 by 5 and then we subtract 1, so dx. And now we see if we divide by 25 both sides, so 25 here as well, so that would cancel out, and then here we have already, so we have x dx here. This we finished from this, so we said this is equal to u is equal to 2 plus 5 x to the power 5, so we are done with that. Now we have x to the power 4 dx, that is already equal to du divided by 25. Then we replace those two by du divided by 25, and we replace this by u, then that means u will be to the power 10. So let us continue and see what we have here for this integration. So we write it again. So again our integral, so we had previously, so x to the power 4, 2 plus 5 x to the power 5, then all to the power 10 dx. and then we said that is equal to, so this we change it to be u, but now we do not forget this, so to the power 10, and everything here else, this one, so we say this is du divided by 25, so that means this is du divided by 25. So then, because 1 over 25 is constant, we can take it outside of the integral, then we integrate u to the power 10 with respect to u. So now we have 1 over 25 times here, so we have u to the power 11 divided by 11 and then plus the constant. So now this we can also take out, so then we will get 1 divided by 11 times 25, because it is a constant, this 11. So and then here we need to resubstitute, or we need to change u to so u was 2 plus 5 x to the power 5, so we need to change it, and we say okay, u is 2 plus 5 x to the power 5, but now u is to the power 11, so we don't forget it, we also put it, and then plus constant. So that is all for this one. So example 2 for the integration, so this is example 2 by substitution. In the second case, we can take this example, so we say okay, we have example maybe x to the power 3 now this time, and here we have sine of say 1 minus 2x to the power 4 dx. So now again, I mean this actually we did not introduce yet, but nevertheless we can do it, and then maybe in the next video we can introduce it. So because now this is different from the second case, so this is the third case that I will be introducing in the next video or in the coming videos. So but now let us do it now. I mean here again we have a function and we have its derivative, so again we don't care about the sign, negative or positive, and we don't care about those numbers here. So we only see that the exponent of x will be reduced, I mean assuming that there is no other x here again, so only we have one x to the power 4, and then after we take the derivative, then that will be reduced to 3, so then we have here outside x to the power 3. So that means this is also integration by substitution, and then we need to assume. So let us assume that again, follow the same way that we did previously. So and then here we assume u to be 1 minus 2x to the power 4, and then the u will be, so the derivative of 1 is 0, then here we have negative, we multiply, we get 8, and then that will be to the power 3 dx here. We can here divide by negative 8, and we'll divide by negative 8. I mean the reason why we divide by negative 8, because here we have the coefficient of 1 for the x cubed, so then this would cancel out. Then here everything in the new integral will be replaced by du divided by, or negative du divided by 8. So and then we're done. So we can say the following, so we can say integral of x cubed sine, so it's always better to rewrite your integral just to avoid any potential mistakes that one can do. So dx, and then here that will be equal to, so now this is sine u, so that will be integral of sine u, so, and then x cubed times dx is, we said, so that will be negative du divided by 8. So this is here is times, so and then we can take negative 1 over 8 outside of the integral, and then we have this nice integral, which is integral of sine u du. So I mean of course, so do it step by step, but then I mean the integral of sine u is negative cosine u, because when we take the derivative of cosine, then you get negative sine times negative, then you get sine. So plus a constant. Here the negative times negative will be positive 1 over 8, and then here we need to replace u again. So u was this 1 minus 2x to the power 4. So we write it here, 2x to the power 4. So then plus a constant. So now we finish from this. I mean, before we coming to the next examples, let me quickly, since I said this, introduce the third case for the integration by substitution. So the third case, if you have this, I mean, if you have let us say anything, you have a sine of f of x, you have cosine of f of x, you have e to the power f of x, and you have natural logarithm of f of x, and so on. But then here all of those times the derivative. So the derivative of this function inside here, the derivative, and then here times the derivative of this function, here times the derivative of this function. So then here dx, 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 and so on. So this continues. I mean, in such integral, that is also directly integration by substitution. So, and we will be doing some examples to cover all cases for integration by substitution, and then we will continue with the integration by parts and by partial fractions and so on. And thank you very much for watching the video, and if you like the video and interested in receiving more videos, please do not forget to subscribe to the channel, and thank you again.